Okay, so last section in this whole chapter, chapter 3, we're doing quartiles and box plots. So we're going to calculate quartiles, and then we're going to use quartiles to create the 5-number summary, and then we're going to actually construct box plots, which represent the 5-number summary. So it's like another graph in our arsenal with histograms and dot plots and stem leaf plots and everything. So quartiles are similar to percentiles of what we did yesterday. Quartiles are still a measure of location. So I could have, so quartiles, if we think of it in terms of 100%, because that's what percentiles were, I can cut 100% into quarters. So I have like the first quarter of 25%, the second quarter of 50%, and third quarter of 75%. So these are the 3 quartiles that we actually want to calculate. So quartile 1 is written like that. And I would say this is the first quartile, which is the exact same thing as the 25th percentile. If they ask you to find the second quartile, that's the same thing as the 50th percentile, which the 50th percentile, I don't know if I mentioned it yesterday, but this is also the median. So the second quartile is the median every single time. And then the third quartile is the 75th percentile. So what this means, so like quartile 2, if it's the 50th percentile, that means 50% of my data values should be smaller than this number that represents the second quartile, and 50% of the values should be larger than it. Same thing with the first quartile. I should have 25% of my data values smaller than the quartile 1, and then 75% larger than quartile 1. Okay, so it separates data into halves, into quarters, all the things. So we're going to actually calculate all of these later. We also have 3 other ways with quartiles that we could generate. So we have 3 different words here in our quartile range. This one is used most often. It is labeled IQR for interquartile range. It is basically calculating the range. So when we did range normally, that's just the maximum value minus the minimum value. But if I'm finding the range of my quarters, essentially, I'm taking the third quarter and I'm subtracting it from the second quarter. And that is how we're calculating the interquartile range. If I was calculating the semi-quartile range, I'm still finding the quartile range, but then I have this word semi in there. So technically, we are having this quartile. Okay. Mid-quartile, so same thing. I have first quartile, third quartile. I want to find the exact middle between these two. So essentially, I want to average the first and third quartile. So I'm going to add them together and divide by 2. So they're all similar to each other. The semi-quartile and mid-quartile, they aren't used very often. It's just this one is most frequently used, but these are other things that we could generate and calculate with everything else that we've been calculating this whole chapter. Okay, we have 2 different examples. We have one with range, one with ages, and one with GPAs. So I'm going to find the quartiles, so that's all 3, first, second, and third, the interquartile range, semi-quartile range, and mid-quartile of the data set. So when we do this, we're going to do it exactly how we calculated the median. So when we found the median, I had to list all of these data values from least to greatest. So that's what we're going to have to do here. So my ages, my smallest one is 17. And then we have 18. And then 19. 20, 21, 22, 2 22s, 24, 25, 26. Okay, so I would start with quartile 2 here. So halfway between all of these numbers, these ages, is, so if I just, 21. Okay, so that's half my data values are in front of 21, half my data values are larger than 21. because I have 5 and 5 on each side. So that's my second quartile is the value of 21. Since we use 21, we can't use it when we calculate the first quartile. So the first quartile, I am looking at the first half of the data. And the first half of the data are these 5 terms. So then I want to find the median of the first 5. And the median of the first 5 is this wonderful 18 value. Same thing, the third quartile, I want the median of the second half of the data. And so the second half of the data are these 5. I want the median of these 5, which is 24. That's the exact middle. So that's how you find quartiles. I can now do the interquartile range, which is just taking my third quartile minus my first quartile, so 24 minus 18, which is 6. So that one's done. Semi-quartile is taking my interquartile range and dividing it by 2. So 6 divided by 2 is 3. I could find my mid-quartile, and so that's averaging my first and third quartile. So 18 plus 24 divided by 2, that's 42 divided by 2, which is 21. So that's how we calculate that. I can do the same thing with GPA scores. We're doing it again because now I have 10 data values, so it's a little different of how we calculate the quartiles. Because ages, I had 11 data values, so there's the point exactly at the halfway point. I still need to write these in order from least to greatest, or greatest to least. Technically, it doesn't matter. So 2.4 is the smallest, 2.6, 2.8, 2.9, and then we have 3.1, 3.2, 3.5, 3.7, 3.8, 4.0. Okay. So same thing, I want to find all my quartiles. So starting in the exact middle, so I have 10 data values, so I should be at like the 5th and 6th one, so looking at these 2. And just like we did median, if there's 2 in the middle, I should average the 2 together. So the middle of 3.1 and 3.2 is 3.15. Okay, so then since 3.15 is right in the middle of this, that's not including a data value, I can cut this in half. So the first half is what I'm using to find the first quartile. So I am including 3.1 in my first half of data. So I'm looking at the first 5. The median of the first 5 is this 2.8. So that's my first quartile. The median of my second half is 3.7. And then same thing, I can calculate the interquartile range. So subtract, which is 0.9. I could do the semi-quartile, which is 0.45. When I divide it by 2, I could do the mid-quartile. So that was adding 2.8 plus 3.7 divided by 2. I think that's right, so 3.25. Yeah. Also, I forgot to mention, I forgot this. So we have to make sure that we're following our rounding rule for statistics. So GPA scores, they were all rounded with 1 decimal places. So when we actually perform calculations with our GPA scores, I should be rounding to an extra digit. So I should be rounding 2 digits, not just 1. So like my first quartile, I should be putting 2.80 here. Oops, 0. 3.70. And all of these should actually have 2 decimal places. Same thing if I went up to my ages data. My ages were 2-digit numbers. I need an extra digit to represent all of my calculations. So technically, all of these should be point zeros on here. And it seems excessive, but that's just how statisticians use their calculations and do them. Okay, so moving on. We're calculating the 5-number summary. So the first number in the 5-number summary is the minimum value. Right, so if you have a list of data, minimum value is the very smallest number in my data. So my GPA scores, that was 2.4. My second number in the 5-number summary is the first quartile. And we have the second quartile, and we have the third quartile. And last but not least, we have the maximum value. So these are 5 calculations, 5 numbers to represent the 5-number summary. Not sure why this is the fancy name, but that's what it is. We use all 5 of these data values to create a box plot. So I'm going to say this is a visual way to graph or represent the data of the 5-number summary. So it's kind of like we have mean and standard deviation, which we use a histogram for. If I'm calculating the median or the quartile, first and third quartile, I use box plots. Every specific kind of calculation is associated with a certain type of graph. So if you're ever calculating first and second, third quartiles, those are always represented with box plots. So box plots, if you've never seen one, I'll just do a rough sketch of one. So they have a box and they have a line in the middle of this thing. It could be exactly in the middle, it could be to the left, to the right. I'll just do it slightly off so that way, you know, it doesn't have to be in the center. This first line in the box is the first quartile. The one in the middle is the second quartile, and the one behind is the third quartile. So those are 3 numbers in my 5-number summary. And then they place points for my minimum value and my maximum value. And then they connect these to there. So sometimes you hear this is called a box and whisker plot because these little line segments are like the whiskers of a cat, essentially. Like, I don't know where they come up with these names, but that's the thing. So, and you have to draw this on a number line. Has to be drawn with a number line. Otherwise, your graph isn't correctly depicting the data. Okay, so we're going to draw a box plot of the GPA scores data. So I already calculated the first, second, and third quartile, and I just need to find the minimum and max. So minimum is 2.4, and my max is 4.0. So all of these have to be graphed on a number line. I'm going to count by 200s, I guess. So here's my number line. Starting at 2.4, it can increase by 200ths. Okay, well, my number line's a little long, but that's fine. Okay, so my minimum value I said was 2.4, so I put a dot above that part of the number line. And my maximum value was 4.0. My quartiles were 2.8 to 3.7. So that's where my box is going to be drawn to. So 3.7 was like right there. And then my second quartile was 3.15. So that's slightly less than 3.2. So there's my line. And I can connect all this. So there is my box plot of the GPA score. This one, if I'm trying to like analyze this box plot, I would say this looks fairly symmetric because my median line, the second quartile, looks fairly in the middle of my entire box. Like it's slightly to the left, but that doesn't affect anything. Same with like my extra line segments over here. Those are fairly symmetrical. They're about the same length. So if I was going to graph this with a histogram, I would say it probably looks like a normal distribution graph based on what this box plot looks like. Okay, so with what we've been doing, I can actually identify outliers before we just define an outlier. It's like a number that's larger or smaller than every other number. So there wasn't really like a set way to actually figure out, is it actually an outlier or am I just assuming this number is an outlier? So with box plots in our quartiles, there is an actual calculation that we can do to determine whether a number is an outlier or not. So this calculation is taking the interquartile range and multiplying it by 1.5. So a value is an outlier when it exceeds like the second quartile plus this whatever. Oh my gosh. Okay, let me explain. So it's an outlier when it exceeds this. So the second quartile, that's the median. I'm adding whatever I calculated with my interquartile range times 1.5. If an outlier is larger than this, or if a value is larger than this, it's an outlier. But I need to be looking at smaller numbers to represent an outlier, or when the value is smaller than the second quartile minus this. So like I'm finding two like boundary lines. So if my value is larger or smaller than my two boundary lines, then it's an outlier. Every other value should fall in the middle of these two things. So we'll do an example, but if I actually do have an outlier, I have to create a modified box plot. So in a box plot, outliers are drawn with a singular point and the min-max value is the next closest data value. Okay, so if I was doing a random box plot here, I would have a line segment, and maybe I have an outlier that's smaller, so then I have an extra one. Maybe I have like 3 or 4 outliers over here, right? So all of these singular points, these are outliers of my graph. Okay, so I want to figure out, does the GPA score have outliers? So my GPA score, I need to figure out what is my quartile 2. I need to figure out what is my interquartile range, and then we'll multiply it by 1.5. Okay, so quartile 2 is 3.15. My interquartile range we calculated as 0.9. Holy cow. I am creating the video so holy cow. Okay, so I need to multiply the interquartile range times 1.5. I need to figure out whether it's an outlier or not, so 0.9 times 1.5 is 1.35. So I need to add the second quartile to my value here. So 3.15 plus 1.35 is 4.5. I also need to subtract this. Okay, so basically if there's any value outside of this range, then that's considered an outlier. Every value inside these is just a regular old value. So if I'm looking at it, I had a min value of 2.4 and a max value of 4.0. These both fell into my range, so technically I did not have any outliers. If I had a random person that had a GPA score of 1.5, that's smaller than 1.8, so that would be considered an outlier, and I have to draw a point. Okay, so this is my last one. I just want to analyze this graph just to make sure we know how to actually describe the data given a box plot here. So we have The distribution of time spent watching TV separated by gender. So I have males as the first row and females as the second row. So you can see I have all of these little dots here. These are all considered outliers based on the data here. I could approximate the medians of both of these. So the median for men is maybe like 550 minutes. And heck, maybe that's not even minutes, it just said time, so who knows. And then females, my median or my second quartile, maybe that's like 450, okay? So if I was trying to analyze this, I would say males watch more TV based on their medians. I could say this data, since I have a longer stem on the right side, I could say they're both, skewed to the right. What else could we say about this? I mean, maybe since this box is longer than this box, maybe say the distribution for males is larger. Right, distribution is talking about like the spread of the data. Maybe they're more dispersed than females, which is clustered more around 450, their median, than the males at 550. But I mean, they look fairly the same, but the males is technically larger. Maybe that's all I want to say. One thing to note, just so that way you remember how this works. If this is skewed to the right, this value we said is the median. If I asked you to approximate the mean, we should be able to do that. So if any data is skewed to the right, that means my mean is also skewed to the right, because mean is not resistant to outliers. Median is resistant to outliers, mean is not. So if I said approximate the mean for the female data, maybe the mean is actually 500. Right, because it should be larger than the median of 450. I'm approximating, it could be 550, it could be 600. It just has to be any number larger than 450 because I'm getting pulled to the right side of the data. Same thing with my men. My mean for men could possibly be like 600 minutes instead, just because same thing, males are also skewed to the right.